Okay, good.
You want to swim from one side of a river to another side. Assume your speed is 3 miles per hour in the west direction, with negligible water velocity. When you reach a certain point, you will encounter water flow with a velocity of 6.2 miles per hour in the north direction. What is your resultant speed and direction? It may help to draw a picture.
3 miles. Okay. Water in the north direction. Okay. I think we can safely assume it will be in the northwest direction.
Yeah.
But the speed, I'm not sure yet.
What's our formula for this?
Mhm.
Says to draw a picture.
Yeah.
So we have a river. You're going this way, and then it hits water that's going 6.2 miles per hour. What is your resultant speed? I want to say that it would be easy and you just add the speeds, but I feel like that isn't true.
Can we? What's the parallelism theorem? Can we do something with that on this, or the parallelism law, where you like extend you extend the kind of like, oh yeah, this one right here, where you extend, like you originally you have the 300 or the 300 and the 200, and then you can extend them to find the actual direction. Does that make sense? Does that ring any bells?
Man, I remember us doing that.
Okay, so we have a vector going west
Mm-hmm.
and the vector going north?
Yeah.
Northwest?
Yeah, so we go north. Yeah, I think I'll go northwest. I'm going to draw this on the graph.
Because in order to do that, use that law, you have to have the vectors coming from the same place.
Oh, that's a good point. Well, it says when you hit a certain point, though, right?
So
And you
we
can
could say that the point is the beginning.
Yeah, could we say that?
I'm still trying to draw the triangle, and for some reason, I cannot triangle today. Like, I know what it's supposed to look like, but each time I draw it, like, wrong.
Battery is fully charged.
Battery's charged.
Thank you.
Okay, so with the parallelogram law, what does it find?
It finds the magnitude and the direction. And it can also help us find the angles.
Okay, so we could say the point in the river when we hit the 6.2 would be our point of origin, and our could have been our left all the way or up all the way, and that would help us find the exact direction.
Wait.
But it wouldn't help us find the speed.
Hey, Jay.
Find the exact angle of the northwest.
Hey, Maddie. Susan. Sorry. If he's swimming at 3 miles an hour across the river, and then he starts getting pushed down the river at 6.2 miles an hour as he's swimming, wouldn't he still be going the 3 miles an hour to the west?
Yeah, I think it still will be going, but it'll also be being pushed up as well. So it'll be
He
like
would
at
be.
a slant.
He would be, but he'd still get across the river just as quickly because he's going the same speed.
Well, because it's pushing him down the river. So if you imagine him going down the river, he's trying to go this way at 3 miles an hour, but the river's faster. So then he starts to go this way, which means it's so since he's going in a diagonal now, it's going to take him a lot longer.
Welcome to the club, Jay.
Okay. What's up, guys? What?
We're on the we started on the quiz first, the week 9 group quiz. So okay, well, yeah, I'm thinking maybe that our idea of making the point of origin, that point where the two forces meet, might not work too well because we're just gonna. Well, maybe it would. It feels like we're just gonna get. I'm not sure how to draw that very well on the graph because we're just gonna get two straight lines in different, perpendicular to each other.
Yeah.
Well, wait. Oh, wait. Go ahead. Sorry.
Doesn't help us find distance. So if we used the MPH as like we give it a set amount of time, like an hour, I guess, then one's going to be 3 units long and one's going to be 6.2 units long. And then we can find the direction because they're not going to be the same magnitude.
Right. So could we do something like this where there's our point of origin right there, and then we've got the 3 miles and then the 6.2 miles. And using the parallelogram law, you just transfer over those vectors, and we can see where the resultant vector will be. Is that accurate?
Yeah, but I'm still not sure what the speed would be.
Yeah, me either. Yeah, how would we solve for the speed of that?
Couldn't we do tangent of like 6.2 over 3?
Why would we do the tangent?
Because like I drew like this one, and couldn't you do that to find the hypotenuse? Or is hypotenuse only that's just the longest side, right?
A hypotenuse is only with a
Or is it only with a right triangle?
right triangle. But with the directions north and west, that is a right triangle.
Yeah.
Yeah.
So we can find the distance easily, but that's not something we're asked. Only the speed and direction.
Well, I put the speeds instead of distance.
What?
For the sides of the triangle.
But the speeds help us measure distance because you go that many miles per hour. So I guess if we could see the distance and assume it took an hour or the same amount of time as both ways, then that would be the speed. But the triangle you drew, That doesn't find the right hypotenuse. Unless, I guess if you... Yeah, you find the right, it could be this way. If we flip it around.
Yeah, I need to make it a right triangle now that I think about it.
Okay. Oh, okay, yeah, so since we are doing it, it's just giving us speed. So would we calculate the speed the same way we would distance because we were given units of speed?
Yeah.
What'd you get?
Hmm?
Connor, what'd you get?
I was just asking, since they give us units of speed, would we just calculate speed the same way we would distance? Because the only difference on there, instead of doing 3 miles that way or 6.2 miles that way, it's just 6.2 speed that way or 3 speed that way.
Yeah.
But it's still set up the same way. So what? So what would be the formula for calculating that then?
I think it'd be tangent equals sine over cosine.
To 6.2 over 3.
Yeah, that's what I did.
And what did you get?
It gave me a negative 1.84.
I mean, it is going into the second quadrant, which half of that is negative, but
Yeah.
so question, will we make the 3 a negative then, since we're going, I mean, we put it on a graph, so maybe that was wrong to do, but if we're on a graph, that would be going negative to the west, right?
Yeah.
Yeah.
But when you're looking at a distance, it shouldn't be negative.
Okay, cool.
Because you can't go a negative distance.
Yeah, that's a good point. You say you got a negative number, Jaden?
That's what it gave me.
What did you type in?
I typed in tangent 6.2 over 3.
Are you in radians or degrees?
I'm in radians.
Okay. I'm in degrees and I got a positive number.
Let's go with that then.
So, but are we doing the right thing?
Okay, never mind. That's like a really small number.
Okay, so we have 2 sides and we need one more side. So instead of doing a tangent or anything, let's just do the Pythagorean theorem.
Okay.
So we'll just do the square root of 3 squared, which is 9, plus the square root of 6.2 squared, which I can't do in my head.
Could you say that one more time? You said square root of 3 plus the square root of 6.2?
No. It's the square root of 3 squared.
Plus 6.2 squared?
Plus 6.2 squared, yeah.
Okay.
All within the square root.
I got 6.88.
Same.
I also got 6.89.
No, if you round it.
Yeah.
Squaring those?
What was that, Jay?
You're just squaring those roots? For the 6.2 squared plus 3 squared.
Yeah, and then we're going to take the square root of those to solve for r.
All right.
Is that like our answer, or is that? That's just the length of the resultant vector, right?
Yeah, it's the length of the resulting vector, which should also correlate to the speed
Okay.
that it takes in 1 hour to go that distance.
And then do we need to find the exact direction? I mean, we have an arrow pointing in the direction it's going, but do we need to find an angle?
Do we need to?
Yeah. Or can we just leave it?
What is your resultant speed and direction?
Right. So I'm not sure if they're asking if to show the direction, do we need to find an angle for that direction, or can we just leave the arrow there and that's good enough?
I think they want the angle.
Okay. So then since these are right triangles, we can assume 90-degree angles and then
Yeah.
30.
And then we can find the angles because we have the sides. So, let's see. We can either do tangent, opposite, adjacent, or we can do sine of opposite hypotenuse, or cosine. Oh wait, no, that one's opposite hypotenuse, cosine, adjacent hypotenuse. Which one do you want to do? I like doing sines.
Let's do sine.
Okay. So, in our little triangle, we want to find this one. The angle from west to north.
From west to north. Yeah.
Okay. So we can do the sine of 6.2 over 6.89.
Okay, that gives me 0.016. Try that one more time just to be safe.
Which numbers did you use in sine?
6.2 over 6.89.
Oh yeah, I forgot that part. I was like, huh. I put the 6.2 in there, but it's not making sense.
Yeah, and let's just check it by doing the tangent too.
Okay.
So opposite over adjacent, which is 6.2 over 3.
Different.
It's different?
Yeah. Not like a ton, but for the sine, I got 0.016. For the tangent, I got 0.036.
That's really different. Also, it doesn't make sense in my brain.
3 squared plus 6.2.
And you're in degree mode?
Mm-hmm.
Mm-hmm.
You got the same thing?
Yeah.
That's really weird.
Let's see. Sine.
That's a very small angle.
Yeah. Well, since we are dealing with, do we need to even do the calculations to find the angle since we are dealing with right angles? Because we've got like we've got north and west, and so we've got 2 right angles, right? Right there and right there. You can assume those are 90 degrees.
Mm-hmm.
So we know the other 2 angles have to be 30, 60, right?
No.
No? If you have a 90-degree angle, you have to have 30, 60.
Yeah.
They have to get out up to
25, 65.
That's true, but
I think that's only if like the sides are a certain length corresponding to each other.
It's like if you have this,
mhm.
but then it can be like shorter here, and then it's a different. See,
Yeah. Okay.
doesn't have to be 30/60. So with this one, it's saying that it's like super close together like that, which means the other angle has to be huge. Or like 89 point something.
Okay.
Doesn't
So,
really make a logical triangle, does it?
well, do you guys want to move on to the second problem and come back to this one, or do you want just for in the interest of time?
So we have to make a rectangular equation for the polar equation. R equals la-di-da. Okay, so r squared equals x squared plus y squared. Is that what we're doing here? And then first let's write out what is rectangular form.
Okay. But, did the homework on it, but I don't remember what rectangular form is.
Yeah.
For the polar equation. Okay, so if we got that. So what if we multiplied? Oh, okay. What if we multiply just the bottom over to r, and then we could get because if we did that, then if we multiply that over, we could get we can make that become y or x, right? If we've got r sine and r cosine, those are equivalent to x and y, right?
Yeah. I think so.
I don't know if having a number in front of the cosine and sine make a difference, though.
Yeah, I didn't have any that had like an actual number other than 1 in front of the cosine and sine in the homework.
3r. So if we did do multiply it over, we get 3r sine theta minus 7r cosine theta equals 10. So then can we make that like 3y minus 7x equals 10?
That's what I was wondering.
Like that? Maybe. But then from there, what do we do? Would that be it then? Or I guess we could bring 10 over to the other side, so make it be 3y minus x minus 10 equals 0.
Should we find it in terms of y?
Sure, we could do that too. Yeah. So you mean solve for y then?
I think that would be good.
Okay, so in that case, we just get y equals 10 plus 7x divided by 3.
Yeah. Awesome.
Why do we solve it? Why do we write it in terms of y though, just out of curiosity?
Just because that's a common thing to do, is write it in terms of y.
Okay.
For equations that you graph and stuff. I don't really have a deep reason for it. Write a polar equation for the rectangular one. So we're just going to substitute in cosine and sine.
Yeah, so if we get, what would that make? That get us r cosine squared and r sine squared?
Yeah.
Does it become r cosine theta squared plus r sine theta squared? And then are we gonna do the same thing on the other side too? Just substitute in sine and cosine for y and x?
Yeah. Yeah, we would.
Then we should get something like this.
Yeah. Do you think we should simplify it?
What would we simplify it to? Would we just solve for r then?
Do in terms of r, yeah.
Sure, that probably sounds like a good idea to me. So could we cancel out? We could probably just cancel out, right? Because we'll multiply. Well, could we just multiply r squared cosine squared theta, r squared cosine theta squared to the other side, and that's going to cancel out. Well, they just cancel each other out if we've got. We multiply cosine over, cancel that out. Divide sine over, cancel the sine out.
I don't see why multiplying cosine would make it
That's true.
cancel.
Good point. Could we make that? Okay, well.
Plus, we can't.
Oh, because it's addition.
Sine is properly distributed. You can't split up the fraction.
Okay. So how should we proceed? Any ideas? Anyone? Could we factor out like an r or something?
This is not easy. Fun fact.
Oh, what if we divided?
Okay.
Or what if we subtract?
Okay, so on the left side, it has r squared cosine squared theta plus r squared sine squared theta.
Mm-hmm.
Would we factor that and take out the r squared?
Let's try that. So then we just have r squared times cosine squared plus sine theta squared.
Mm-hmm. And then we can, let's see, factor the other side as well. Take out r squared, r squared.
Factor out r squared.
Yeah.
That's going to be 9r.
9r squared okay. Since it's r squared over r squared, you have to have 2 to factor it out.
Oh, so would that be the same on the other side as well? We'd have 2r squared. Well,
No, because like if you have x, y, and x, y, and you factor out an x, it's just x and y.
good point.
Okay, so with the right side, we have 9 times r squared cosine, or is it cosine or sine? Let me look here.
Sine.
It's sine.
Mhm.
Oh yeah, because it's y. So we have
So then,
r sine squared theta over r squared cosine squared theta.
oh, so we're just factoring out 1r, not both r's, just the 1r?
Let me think. If I had xy over xy, since it's multiplication, you can cancel out the r squared, right? Since it is an
I think
addition.
so.
If it was r squared plus cosine squared on the bottom, then you wouldn't be able to take it apart. But since it's multiplication, the r squared over r squared cancels out, right?
I think that's right. I think that's something we could do, yeah.
Yeah, so then if we divide everything by cosine squared theta plus sine squared theta, which is on the left,
Mm-hmm.
then wouldn't something cancel out? So you're gonna no, wait. X divided by y over x plus y.
I see what you're saying. Let's see.
Let's multiply by cosine squared theta. And get that out of the fraction.
So we're multiplying the cosine squared theta over to the left side.
Uh-huh.
Okay. So that will just do
Cosine to the fourth theta plus sine squared theta cosine squared theta.
wait, I'm sorry. So you said cosine theta to the fourth?
Cosine to the fourth theta.
Cosine to the fourth theta. Okay, why is it to the fourth theta instead of cosine theta to the fourth?
Because that's making theta to the fourth instead of cosine to the fourth. Remember when we learned that those are different things?
Yeah, I'm wondering if I wrote something down differently than you then, because everything I have, everything is theta squared.
It should be squared theta.
Squared theta. Okay. Okay, then yeah, go ahead. So it's gonna be it's gonna be on the left side, then it's gonna be r squared times cosine squared theta. I'm sorry, it's cosine to the fourth theta.
Plus sine squared theta cosine squared theta.
R squared times.
And all of this is equal to
9
times sine squared theta, right?
Okay. Jared, Jaden, you guys have any thoughts?
Sorry?
You guys have any thoughts?
Yeah, sorry, I'm not much help this week.
Oh, you're okay. I just don't want to exclude you guys or anything.
Yeah.
Yeah, so I've got I'm not sure I'm getting the left side down right. It's r squared times cosine to the fourth theta plus cosine to the squared theta.
Plus, okay, so it's r squared
Mm-hmm.
and then times cosine to the fourth theta plus sine squared theta cosine squared theta. They're multiplied together.
Okay.
Because I'm
So
distributing the cosine that we multiplied over, and I already distributed it in.
do you have it written down just so I can see it? I'm just having a hard time following it.
Actually, no, I've been doing it in my brain. So let me write it down. Where's my pen?
How do these people keep getting your number?
Hello? Okay. So it is our.
How come all of the people that call like the time?
No, just a heads up, guys. Sorry, I have to leave in about 5 minutes. I can leave this up though, and you guys can finish, and I'll just turn it off when I get back.
And multiply by cosine squared theta. La-di-da. And then that's going to be r squared cosine fourth theta plus sine squared theta cosine squared theta equal to 9 sine squared theta. See that?
Oh, sorry. Okay, yeah, okay. Yeah, okay. So then what do we do? Can we just divide that all back over to the other side? And then take the square root of that, and now equal r? Oh, are you guys still there?
I think Susan froze.
Yeah, I don't see her either.
She said her internet's not good today.
No, there she is. Now she's back. You froze for a second. So then will we just divide all that over to the other side? And then to take the square root of that, and that's equal to r?
Yeah. Just make sure to distribute the negative when you subtract.
When we subtract?
Yeah, because we're moving over the cosine to the fourth theta, la-di-da-di-da.
When we just divide that over though, since it's all times r squared?
You're right.
Divide la di da di da.
La-di-da-di-da. Okay. That's an ugly number.
And
Well, it's a word, so it would be ugly, wouldn't it?
Yeah.
La di da di da. That'd be an ugly division problem.
3 sine theta over cosine squared theta plus sine theta cosine theta. Is this what you got?
Sine. Oh, I see. Yeah. Yeah, I just left it under the square root. I left it as is, but yeah, we could definitely simplify it.
Actually, on the bottom, since there's addition, let's just leave the whole thing under the. And if she tells us it's incomplete, then that is sad. Okay. Graph the polar coordinate la-di-da. An ordered pair in polar coordinates names a single point. However, the coordinate is not unique. Name 2 other polar coordinates that are located at the same place as 4 pi over 3.
Okay, so the angle is the 4 pi thirds. Well, this is pretty easy, right? It's just like a distance of 4, like on that, those graphs with the circles on them, right?
Yeah. So
Wow, bless you. So then, so we have like a graph like that, and then we could plot it since it's just gonna go over 4 and then up to where that angle is, which is what, 4 pi. Is that making sense so far? Is that right? 1, 2, 3, 4, then go wherever that angle is.
And then it'd just be up 1 over 1, up 1 over 1 from there.
Yeah, and then whatever 4 pi thirds is, that's 4 pi thirds. Where is that on the unit circle? How do we? It would be the same as like pi thirds, just so it's like 60 degrees.
It's at 240 degrees is 4 pi over 3.
Oh, yeah, okay. So then it's gonna be so it'll be in the third quadrant.
Yeah,
Yes.
did you say 240 degrees?
yeah.
Okay. Good deal.
So we got
I printed
the
one out in my notes.
okay. So then, what is? How do we find the 2 other coordinates? What do we just go around again, and then we could say we could call that. No, that wouldn't be 5 pi thirds. Huh?
Okay, so 1 second. So I'm confused a little bit.
Oh, is it like one is positive and the other one's negative, so it's like the other way around the unit circle?
Oh, good point. So we could say like whatever it is, negative.
Yeah.
Something like
60 degrees has the same angle, I guess.
60 or 120. If we're going negative.
If we're going negative,
Negative 120. So negative 3 pi over 2.
Okay.
With it still being 4.
Other coordinates. So 4 comma negative 4 pi over 3.
And then we can just add 1 full unit circle to 4 pi over 3, right?
That's what I was thinking, right? And then just what would that make it though? Would that be because that wouldn't become 5 pi thirds because there's already a thing.
So you add 2 pi.
Oh, 6 pi thirds. Oh yeah, right. You have to add 2 pi. Yeah. Okay.
So 2 pi plus 4 pi over 3. Yeah, wouldn't that be 6?
6 pi.
Over 3.
Oh wait. 2 pi plus.
Which you can simplify to just. That simplifies to 2 pi. So that's wrong. No, you add 6 pi over 3 to 4 pi over 3.
There we go. Yeah, because it's a fraction. Okay, so we should get 10 pi over 3, right?
Yeah, 10 pi over 3. Because we have to put it in the common denominator. Add across.
So, like that.
Yeah, that looks perfect. Wait, negative 4 pi over 3?
If we're going negative.
Yeah, shouldn't it be negative 2 pi over 3?
Yeah.
Oh, yep. You wait. Yeah,
Other
you're right.
than that, doesn't. I don't know. Because wouldn't it have to be line up with the negative 240?
It does.
Yeah,
Oh, it does actually. Never mind.
the reference angle. Nice
I
save.
always
there.
get confused on the unit circles because they don't have like the negative corresponded as well.
You just have to do it in your brain.
Okay, well, I actually have to go now.
Well, that was the last question, right?
Yeah, we were
Yeah.
gonna go back to the first one and see if we could figure anything else on that, but
Let's just say speed 6.82, and let's just put what we got, and then we can write to the side that we were confused.
okay. And would you mind sending me a picture of your work too for that second problem, just to make sure I did it right?
Yeah. I sure can.
Well, usually, Jay, we have donuts and stuff, and we're watching Netflix while we do this. So next time it should be more interesting.
Oh, that's awesome.
He's lying. We're boring.
I'm yeah,
Oh no, next week I'll know which quiz you're doing, so I'll make sure I'm more prepared.
no worries, man. No worries at all. Okay, cool. So I'll send you guys all a picture of this you guys have for studying or whatever. And yeah.
Awesome. Have fun
Sounds
at
good.
Winter and say hi to Isabel for me.
Will do. Do you guys want a picture of her too?
Yes.
Yes.
All right.
I'm a deprived college girl and I need more pictures of babies in my life, so.
Okay. All right. Talk to you guys later. Stopping broadcast.